Today in the Physics Funhouse, we are discussing energy. The classic definition of energy is the ability to do work, but the term work may not really mean that much to you yet. A little more broadly, we can say that energy is a quantity that could cause something else to move. So if you have the ability to make something else move, you have energy. Really what energy is, it's a useful accounting system. And it's a useful accounting system because it's a quantity that is sometimes conserved. And so one thing we're going to study is what systems is energy conserved for and how is that useful. And then more broadly, energy allows us to connect the mechanics that we study in Physics 1 with many other fields of study. For instance, chemistry can be connected to physics via the concept of energy. And so what we're going to do today is we're going to look at a couple of different forms of energy. These are all examples that we may be familiar with already to see if we can start to get an understanding of what energy means and why it is useful. So typically the first form of energy that we study is kinetic energy, which is energy through motion. And so if this thing is moving, then it has the ability to make something else move. And so if I give the blue card a push towards the red card, you'll notice that as a result of the blue card colliding with the red card started to move. And so we could say that because the blue card was moving, it had kinetic energy. Now you might be saying to yourself, well, wouldn't that be true also of momentum? Would momentum mean that this thing has the ability to make that thing move? And it could, but not in a more general sense. And so it's possible within a system of objects, like the two cards together, to have zero momentum, but still have energy. And so the term energy is better for the ability to make that thing move than the term momentum. The next question might be, how did I make this thing move? So this thing got energy because I pushed it. That means that I did work on it with my little finger. Another way that I can make this thing move is by popping out that little spring plunger that is right here on the side. And so that spring plunger being coiled in, I push the button, it pops out, pushes it, and causes it to move. So the spring plunger has a different form of energy that we're going to refer to as potential energy. Potential energy means energy through position. And so because the cart was in a system with the coiled up spring, when it was pushed up against this, we say that the cart has potential energy due to its position with this spring. And so when the spring then is released, the cart loses potential energy and gains kinetic. And so once we learn the different forms of energy, we'll then study their transformations. So potential energy is energy through position within a system. And there are several different kinds of potential energy, or subflavors, if you will. So a good example of potential energy, or energy via position within a system, would be a simple pendulum. This is just a 1 kilogram mass tied to a string, which is connected up there to the ceiling. And right now it's not doing a whole lot. But if I raise it a little bit, like change its position, and then release it, now you notice that it has the ability to move. And so when it comes back to its equilibrium position, it doesn't just stop, but it keeps moving. This is also a good illustration of the conversion of energy from one form to another. You'll notice that when it reaches the end of its arc on either side, it comes to stop. And then as it moves downward, it's moving relatively quickly down here at its equilibrium position. The higher I raise it to begin with, the faster it moves at its equilibrium position. So a pendulum is a good example of gravitational potential energy and the conversions between that and kinetic energy. It's also a good example of how energy is usually easier to use than forces and Newton's laws. If I were to use forces to study the motion of this thing, that would be kind of complicated because the angle of the string force is changing and the component of gravity that's parallel and perpendicular to that string is changing. So it's a complicated problem using forces and Newton's laws. It's an easy problem using energy. So next, let's talk about what the whole system thing means. The only reason that this thing has the ability to move when I raise it and then release it is because it's in a system with the Earth. The Earth is the thing causing it to have energy. If the Earth were not underneath my feet right now, one, this would be really hard to film. Two, this thing would not have any more ability to make things move when I pulled it back. And so it's very important that we realize that potential energy means energy through position within a system. In this case, the system would include my pendulum mass and the Earth itself. Another good example of energy through position would be like a simple dart gun. A dart by itself, doesn't really do a whole lot. But if I put it inside this dart gun, like that, it still doesn't do anything. If I change the position of the things within the dart gun, namely if I pull this thing back and I coil the spring that's inside of there, now the dart had the ability to move. If an object is in a system that contains a coiled or stretched spring, it would also have potential energy. Another good example of that would be a rubber band. Stretch a rubber band out and let it go. You can cause the rubber band to make things move. Let me demonstrate for you the factors that affect the elastic or spring potential energy in a spring system. And so I'm going to take this blue spring that's just hanging from a rod. I'm going to hang a 500 gram mass from it. And you'll notice that that causes the spring to stretch out a little bit. And so remember that the stretch of a spring is proportional to how much force is exerted on it. So if I pull harder, it stretches more. The same thing is going to be true about the energy of the spring. And so if I displace it downward just a little bit more, notice that it kind of oscillates like our pendulum did, and it moves like fast as it returns to its equilibrium position, and it oscillates back and forth, returning to the same position each time. If I were to stretch it out more, notice that I get a bigger oscillation, I get more movement. So the more you stretch the spring, the more potential energy in the spring, whatever is in the system. The stiffness of the spring also plays effect. And so if I were to hang 500 grams from both of these springs, notice that the blue one stretches more than the green one. That means the spring constant of the blue spring is less than the spring constant of the green spring. So this one is stiffer. It requires more force to stretch it. And so when I release both of these, displace them about the same amount, you'll notice that I get a lot more motion out of the green spring than I do the blue spring. And so the second factor that affects the energy of a spring whatever system is the stiffness of the spring. And so both how far you stretch the spring or compress it and how stiff the spring is affect the spring potential energy of a system that includes a spring. So here we have a good example of how the term energy allows us to connect mechanics, like things moving, with other areas of science. And so the hot plate that beaker of water is sitting on is transferring energy to that beaker, and as a result, those little bits of paper inside the beaker move. The water inside has got a lot of kinetic or moving energy as a result of being on that hot plate. And so we cannot directly study the the motion of those little bits of paper as a result of being on the hot plate solely using forces. We can't see the forces that are going on there. Like, you don't see how the hot plate is pushing the beaker, which then pushes the water, which then pushes the bits of paper. But using energy, we can easily connect what's going on inside the hot plate to what's going on inside the beaker of water. And so that's one of the reasons why energy is so important. Another good example of how energy allows us to connect mechanics to non-mechanical things would be a simple circuit. That battery contains charges which have electrical potential energy due to their position within the battery surrounded by other charges. When you connect that battery to something like a light bulb, you can then see how that energy is released, in this case, in the form of light and heat. And so it would be very difficult for us to study this system using forces and Newton's laws, but it's really easy if we study it using energy. The battery provides charges with energy, electrical potential energy, and then the light bulb dissipates that energy in the form of heat and light. So that is another example of how we're going to use energy to connect mechanics that we've already learned with non-mechanical systems like a circuit or a thermodynamic system. Okay, so to quickly recap, kinetic energy is energy through motion of an object, and that's just our K equals 1/2 mv squared equation to calculate the quantity. Potential energy, that is the energy through position within a system. And that system thing is extremely important. Our two forms we're going to study in detail in Physics 1 would be gravitational potential energy and spring potential energy. And if I haven't already mentioned it yet, the symbol for potential energy is a capital U. But because physicists don't write U's very neatly, usually we draw a capital U with a tail. And then don't ask me why we draw it as a capital U. But the gravitational potential energy equation is simply mass of the object times G, and remember G depends on Earth, and so that's that system thing, times height within that system. And we're going to discuss in a little bit more detail later, like where you measure the height from. And so the first thing to realize about that is that it's relative to your frame of reference. For a spring, the equation is 1/2 kx squared. And again, K depends on the spring. That's the stiffness of the spring. And so that's the system thing. And so it's very, very, very important we understand potential energy is energy through position within a system. So a dart by itself cannot have spring potential energy. A dart that is inside a dart gun can. And so it's only in a system that you get potential energy. So we're going to study those two forms of energy in detail as well as their conversions. And I've got a few more demos that we're going to see a little bit later on. Till then, ta-ta.